The Intermediate Mathematical Olympiad Cayley paper 2020, question 2. The digits 1, 2, 3, 4, 5, A and B are all different and non-zero. Each of the two 6-digit integers, A, 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5A is divisible by B. Find all possible pairs of values of A and B. Now we're told that A and E are non-zero, so they can only be 6, 7, 8, or 9. We have two divisions to consider. Now with this one, this digit is a 5, therefore it can't be, B cannot be 6 or 8 because 5 is odd. So we've already discounted those. So therefore B is either 7 or 9. A can still be 6, 7, 8 or 9. So let's take it one at a time. Let's assume B is 7. So what we've got here is we're carrying 4, so 7 into 4A. So the number 4 and whatever that digit is needs to be divisible exactly by 7. So we're either looking at the number 42 or 49. It's not possible for A, which is this letter, which is this digit here, to be 2, because 2 is already taken. So therefore, A must be 9. So if B is 7, then A must be 9. What if B was 9 instead? So this time we're putting 9 as the division. Now, what I'm actually going to do here is I'm going to add these rather than doing the division. I know that any number that's in the 9 times table is divisible by, if I add the digits together, then the number will be in the 9 times table. So I add those together and they make 15. Therefore, the only way that we can make that more with one more digit is if it was going to be a 3, because 3, we have to be, 18 is the next one, and 27 is too big. We can't have a number that we add to 15 to get to 27. So therefore, A must be 3, but it can't be 3 because it has to be 6, 7, or 8. So therefore, B does not equal 9. Therefore, we go back to here where A is 9 and B equals 7.